In our last lesson, we talked about standard deviation and what standard deviation is. It's a measure of how spread out a set of data is. And then the very last thing that we talked about in the last lesson was the ways that data can be distributed. And we looked at some graphs. One was a negative skew, a positive skew. And the one in the middle was something called like a normal distribution. So that is not an N. There we go. So it was something called a normal distribution. And there is a really, really important relationship between standard deviation and the normal distribution. So when you're told this data is distributed normally, it means something very specific with regard to the standard deviation. So you should have on your notes like a fairly large space to write this, and this is absolutely like imperative that you write this down. It's going to be super hard for you to do your homework or any classwork or anything like that if you don't have this, and you need to write it down because that's the only way you'll get to remember it. I do have the reference sheet for your EOC in front of me, and there is a version of this on your EOC. It's not exactly the same as what I'm going to show you, but I'll try to connect them together for you. So draw a line somewhere towards the bottom of that space, and then above it you're going to do something that looks like a normal distribution. I'll see if I can. That's a little bit better. Okay, it doesn't have to look perfect. It just has to look like a bell curve. Mine looks a little bit off center. So, all right. Now, what that means is that if you had a lot of data values, most of the data values are going to be in this area here. And as you get further out, there would be fewer data. We're doing like the histograms where you were like making the X's. Okay, this is like, just pretend there's a bunch of X's there. Okay, so that's the distribution of the data. In a normal distribution, the mean, the median, and the mode would all be the same number. So the average number, the middle number, and the most frequently occurring number, all of those numbers would match up. And they would be dead center right in the middle of your bell curve. So I'm actually going to label this as the mean. Okay, and so your mean would be right in the center. So it's this, and it's perfectly symmetrical on either side. Now mine doesn't look perfectly symmetrical because I'm a human being and I'm drawing this on an iPad mini. And so it doesn't look quite right. But you can look up a normal distribution online. You see a beautiful, beautiful bell curve. Okay, now that's the middle. Now, for like the sake of illustration, okay, we'll use, say, IQ as an example. So I'm going to make a couple notes over here. IQ is short for intelligence quotient, and it is a number that it measures, it says intelligence, but it measures maybe like a little bit more aptitude, and it's debatable how important that number is. So if you have had an IQ test or something, or you know what your IQ is, you only put so much stock in what that number is, okay? But in theory, intelligence is normally distributed. So there is some average intelligence, and then there are people that are above average and people that are below average, but still within like what we would call like an average band. The smarter you get, the curve goes down, and it means the fewer people are going to have IQs that high, and the same is true going in the other direction. So the lower the IQ gets, the fewer the people that are going to fall into that band. Okay, now for like a fun fact, the average or mean median IQ on most IQ tests, so that's the other thing you want to know is if you have had an IQ test, which test it was, because they don't all measure it the same way, is 100. Okay, that's like considered like the average IQ. Now, the standard deviation for this can vary. And I think like one of the measures, it's like 15 or something. So it's standard deviation of 15. Another one might be a standard deviation of 20. But what we would do, like if we had the average IQ of 100, is we could add one standard deviation. Now notice how I wrote that. I did plus, that means we're adding, so we're going to get bigger, and I use the number 1, and then that's the symbol for a standard deviation. So if the standard deviation was, say, we'll pick 15, okay, then we would add 15, and we would say that this number is 1 standard deviation above the mean. You could also subtract 1 standard deviation, and that would give us 85. And we would say this is 1 standard deviation below the mean. So you've got your average, and you can go 1 standard deviation above and 1 standard deviation below. And you could do that again, and you'd say that is 2 standard deviations above. And then what would this be? 70? Say that was 2 standard deviations below. Now, notice again, I'm going to talk about it a certain way. We would say that between 85 and 115 is within 1 standard deviation of the average, meaning like 1 below and 1 above, it is within 1 standard deviation. So the distance of any IQ in that band from the average would be less than the 115. So what does that have to do with the bell curve here? Well, if you were to go out plus 1 standard deviation to the right, and you were to look at this band right here, exactly 34% of all of your data values are going to be in that band. So if we were talking about IQ, that would mean that 34% of people have an IQ between 100 and 115. And because this is a perfectly symmetrical curve, which now really doesn't look symmetrical, another 34% would be between the 85 and the 100. And we would say 68% of the population, okay, so that's most people, have an IQ somewhere between 85 and 115, or 1 standard deviation below or 1 standard deviation above. And it's not just IQ, it's anything that is normally distributed. So height is normally distributed. We've got an average height for like adult men in the United States. And then there's men that are taller and men that are shorter. And then there's this band around the average height where like 68% of adult men would have a height within that band. The taller you get, the fewer the people like are that tall, and the same going in the other direction. Now, if you go out 2 standard deviations, there are 13.5% of people that are going to fall into that band. So not as many. And the same is true on the other side. Okay, so that's 13.5. And then you can go out 3. Okay, and we'll go like plus 3 and we'll go minus 3. And that is 2.35%. So now you're getting to the area where, okay, that's not that many people. Okay, that might be like your NBA basketball players, okay, are going to be like way out here in this range. These are like your super geniuses, okay? And then it doesn't leave much out here. In fact, most of your distributions are going to leave this part blank, but I usually fill in for you. It's just 0.15% that is left. And if you add up all of these percentages, you will get 100%. And so everybody's covered in there somewhere. And then exactly 50% are going to be below and 50% are going to be above. And that is true for anything that is normally distributed. So I'm going to copy this graph. I think I'm going to copy this graph onto another page, and then I'm going to kind of rewrite it a little bit and show you how that appears on your reference sheet, just so you should be able to go back and forth. I like this way. These are the numbers that I memorize. These are the numbers that I use when I'm doing normal distribution, standard deviation kind of problems, but it's not how a lot of the graphs are given to you. All right, so on your reference sheet down in like the lower right hand corner, and your reference sheet, this is being recorded in the 2020-2021 school year. They've redone the Algebra 2 reference sheet, and it is actually a really good reference sheet. So it's got like a lot of the logarithm stuff on it, your quadratic stuff. And it does have like the probability formulas we've been working with, and it's going to have this chart on it as well. Now, I give this to you guys as 30, good grief, 34% and 34%. The chart that you're going to see draws a line going across like that, and it says 68%. And so what they do is they're giving you the same information, but they're giving it to you in terms of that standard deviation from the mean. They also look like they've got it marked off by half standard deviations. So there's like this other line in there. Okay, so just make sure that you're reading it there. And if you like learn it well this way, you'll be okay for adapting. Now, I give you like the 13.5 and the 13.5. So I kind of break it down into the individual bands. What they do is they draw a single line going across like this, and they add up all of those percentages together. So they're going to do the 68, or like they do the 13.5 plus 34 plus 34 plus 13.5, and they get 95%. And you'll hear that number a lot. It's called like the 95% like confidence interval there, that you're within 2 standard deviations of the average. And then where I give you the 2.35 and the 2.35, they draw like a line going all the way across like that, and they label that 99.7%. Okay, and pretty much what they're doing is they're adding all of that up. Now you can go back and find the values of the individual bands. So if you want to know like how big this band is, you would do like 99.7 minus 95 and then divide it by 2, to make sure that you got you got each side of it. And you could do like 95 minus 68 and divide that by 2, and that would give you the 13.5, and then do the 68 divided by 2, and that would give you the 34. I would encourage you to get as much practice with it in this version as possible, because it will help you adapt to the other version. All right, so let's take a look at like an example problem of something that you might see that would be done with the normal curve and standard deviation. And on my lesson thing, I like put in the wrong upload, but whatever. All right, so let's look at an example problem involving standard deviation and the normal distribution. So the scores on the Algebra 2 final are approximately normally distributed. Usually they're not. Usually they're inversely distributed, like a lot of low scores on a lot of high scores, but like let's just say they're normally distributed with a mean of 150 and a standard deviation of 15. And we got 2 questions there. What percentage of students who took the test scored above 180? And if 250 students took the final exam, approximately how many scored above 135? So the easiest way in my world to do this. So, I mean, if you want to like Google from some random person on the internet, like, I mean, go for it. But like, really, they're not going to show you anything better than this. Okay. So you got your normal distribution, and then we are told that the mean there is 150. Okay, so in this example, like I was just writing like +1 standard deviation, +2, +3. On this one, we're actually going to put the actual numbers. Okay, so it says the standard deviation is 15. So I'm going to do 150 plus 15, and that's going to give me 165. And I might do this up here, like +1 standard deviation. 165 plus 15 is 180. That gives me the score 2 standard deviations above. And then 3 standard deviations above would be 195. Going in the other direction, so -1 standard deviation, we do 150 minus 15, which puts us at 135, -2 standard deviations. My sigma got a little smushed there. I hope that's okay. That's 120. and then minus 3 standard deviations is what, 105. And so now you have, well, you actually can answer several questions. So if I were to ask you what score is 2 standard deviations above the mean, you've got the mean, 1 standard deviation, 2 standard deviations above, the answer would be 180. If I were to ask you what score is 3 standard deviations below the mean, you would go in the other direction and you would answer 105. And it really did not take me that long to put that together. You might have to grab your calculator and do the adding and the subtracting depending on what the numbers are. And then we know several things. We know that this is 0.15%, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. If you can put that together, and it took me less than 4 minutes to put that together, you can answer pretty much any question that somebody's going to ask you about that specific data without having to do much in the way of calculating at all. So the first question that we're asked is, what percentage of the students who took the test scored above 180? Well, once you put this together, here's the 180. You want to know what percentage scored above 180. You would just simply add those two together. So 2.35 plus 0.15, and that gives us 2.5%. And it's like literally that easy. You can read it right off of your diagram. Second question is a little bit slicker. It says, if 250 students took the final exam, approximately how many scored above 135? So that's a little bit trickier because it's not asking what percentage scored above a 135. They're asking how many. So there's a couple ways that you can do this. Okay, the definition of a z-score is the number of standard deviations a number lies above or below the average. And so I'm going to give you 2 different versions of the formula, one that's a little bit easier to understand, and then I'll give you the version that's on your reference sheet, and hopefully you'll be able to connect the dots on that. So the formula is z because it's a z-score, and it is equal to the number in question. Okay, what's like when it says a number, like that's the number we're talking about, minus the average of the numbers divided by the standard deviation. And then the way it appears on your reference sheet is this. It'll say z equals x minus that symbol over the lowercase sigma. That symbol right there is a mu, as in mew. Oh, I can't do it. I don't have a voice. Mew, like a cat. It's a mu. It looks a little like an M and a little like a U. So mu, mu. You should be able to remember that. And that is sometimes used as a symbol for average. There are several different symbols that you'll see for average, and that's one of them. The other one that you might see is that with like an X with a bar over it, and it's literally read X bar. So you could see that as well, divided by the standard deviation. So as an example, it says the z-score for a student scoring 170 on the test above, or in this case, sorry, I made a mess out of this slide. I have like 10 slides on this. Anyway, so we know that the mean is 150. That's our mu. The standard deviation is 15. And then our number or our score is that was like poorly phrased. The z-score for our students in a bus that was awful. I'm looking at my notes. Like, this is horrible. Sorry about that, guys. Okay. So the z-score for someone scoring 170 would be 170 minus the average, which is 150, divided by the standard deviation, which in this case was 15. If you are going to do this on your calculator, you have to watch for your order of operations. So the answer that you should get for this is a 1.3 repeating. Okay? Like it should be 1.3 repeating. Please pause the video, grab your calculator, and make sure that you can do this problem and get this answer, okay? Because there's like a whole ton of you that are going to get like 160 as an answer, all right? And that's not going to be right. So please, please, please make sure that you can get the 1.3. And if you can't, and you can't figure out what you did wrong, please say something. That is why you have a teacher. So like reach out and say, okay, like I'm getting the wrong number. You need to know how to hit the buttons on your calculator. For some of you, it can be alleviated by putting parentheses around that, because you do want the calculator to do the subtraction first, not the division, but it will follow order of operations and it'll do division before subtraction, unless you put the parentheses around it to bump it to the P. You can also manage it this way. You can do the 150 minus 170 minus 150 and then hit equals and then go and do the divided by 15. That can also fix the problem if you hit equals in between the two steps there. So there are a few things. I'm going to go back and look at this. We'll work on this in class, I think. Yeah, we'll work on this in class. There's two of them, and we might do something like where we do one together, and then I'll have you guys do one on your own. But I do want to point out something about this. Let me see if I can go back to this. Remember that the z-score is the number of standard deviations something like a number is above the average. So in this example, the z-score for 135 would be -1 because it is, okay, I don't know when that paused out, but it did, trust me, it did. The z-score would be -1 because 135 is one standard deviation below. And that's like literally the definition of what a z-score is. The z-score tells you how far above or below the average it is. The z-score also can tell you how somebody or like one score is compared to another one. And I'll see if I can give you an example of that. All right, so consider these two classes. Class A has an average of 80% with a standard deviation of 15. Okay, and class B has an average of 75 with a standard deviation of 2. Now remember, standard deviation measures how spread out the scores are, and so standard deviation of 2 is really, really small. It means that like these scores are really clustered right around the 85. These scores are much more spread out around the 80. If you were to calculate the z-score for a student that scored an 85, it would be 85 minus 80 divided by 15. So it would be, what, 5 over 15, which is 1/3 or 0.3 repeating. Okay? And then this student over here has an 80, and so this would be 80 minus 75 divided by 2, make sure I do that right, yep, which is 5 over 2 or 2.5. And so the question that you might be asked is which student actually did better? And the answer to that is, well, you got this student who has a numerically higher average, but this student is actually 2.5 standard deviations above the average for his or her class. So even though this student has a lower score compared to their classmates, this student is doing way better than this student who is still falling within that first standard deviation. So this student is like average for their class. this student is way above average for their class. So it's just another way of getting into the subtlety of that data and numbers that describe different things and can give you slightly different pictures of what's happening. So you should be able to upload your notes now that are titled standard deviation and the normal distribution, and there should be a place in Focus for you to upload those.